Okay, we are looking at dividing polynomials today. So it does start with a just quick review of dividing with monomials, in which you are actually dividing every single term by that 3x squared. So when I do 6x to the fourth divided by 3x squared, I get 2x squared. And then we do my negative 15x cubed divided by 3x squared, I get negative 5x. And then 3x squared divided by 3x squared would just be 1. That's great when it's a monomial, but when we look at today is what happens when it's a binomial. So one option is to use factoring. So you would factor the numerator. So I'm looking for numbers that multiply to 10 and add to negative 7. Negative 2 and negative 5 would work for that. So I'm going to factor my numerator to w minus 2 times w minus 5. Then, because both my numerator and my denominator have this binomial of w minus 5, they cancel out, and I'm left with just w minus 2. And that's great, and that's awesome, and it works when things factor. The issue is, what if what I'm dividing doesn't factor? So what if factoring is not possible? You have two options. One is long division, one is synthetic division. We are just going to focus on synthetic division. So when you are doing that, you take what you are dividing by, set it equal to 0. So pretend as if that was the factor. What would the 0 be? That would be negative 8. That number is going to go in a little box over here. Then, next to that box, you'll have numbers out here in a row. Those numbers are your coefficients from the part that you're actually dividing. So like 1x squared plus 3x minus 43, I'm just using the coefficients. So 1, 3, and negative 43. Then, what you do, always bring down that first number. Then you are going to, whatever's underneath this line there, you are going to be multiplying the number in the box times that. So I'm going to do negative 8 times 1. That gives me negative 8. That's what goes right there. Then I'm going to add those two. 3 plus negative 8 would be negative 5. Again, I'm going to multiply the negative 8, this time times the negative 5. I get 40. I'll add those two, and I get negative 3. Now my answer comes from these coefficients here. It's kind of like how you got the original coefficients, or the original line by using the coefficients of the problem. I'm now going to use these as my coefficients. I started as an x squared. I divided by x, so this is going to be 1x. Minus 5, this number is my remainder. We write it as a fraction, so this becomes plus negative 3 over x plus 8. So that x plus 8 came from up here. Negative 3 is right there. You might also see it written as x minus 5, and then because that was a negative 3, as minus 3 over x plus 8. Those are the same thing. Both are correct. Let's do a couple more. So again, I'm going to start with the number that goes in the box. That comes from right here, because that's in minus 7. That is 7 that goes in the box. The numbers that are listed out to it are these coefficients up here. So 2, negative 16, 19. And then you draw your line. The 2 is always going to come down, or whatever number's first. Then you're multiplying the number in the box with whatever's in that row underneath the line. That's what you're going to get up here. So 7 times 2 is 14. Remember, you're adding those, so I get -2. Again, multiply. 7 times -2 is -14. I add those to get 5. When I write my answer, I should always be bringing my polynomial down by 1 degree, because I've done 2n squared divided by n. That would just be 2n. So I have 2n minus 2, and then that remainder of 5 is written as 5 over n minus 7. Looking at number 8. What I divide by is giving me the number that goes in the box. My coefficients come from here. Now, because this is a y cubed and I'm dividing by y, my answer should start with y squared. Let's go ahead and do it though. Bring down the 1. Two times 1 is 2. Add those to get 7. 2 times 7 is 14. Add those, again I got 7. 2 times 7 is 14. Add those and I get 16. So I have 1y squared plus 7y plus 7 plus 16 over y minus 2. Notice that each time this number here at the end is lining up to be our remainder. And right in front of it, I have the constant and then the linear term. So here I have the constant, the linear term, and then the quadratic. Sometimes you're asked to divide problems that are missing terms. So when I look at this number 9 here, I see that I have k cubed, and then I have minus 17k. I'm missing the k squared. You have to account for that. So this is really k cubed plus 0k squared minus 17k plus 32. Everything else is the exact same. You just have to remember to put that 0 in. So looking at number 10, I have 8x to the 4th minus 64x cubed. Next should be x squared. There isn't anything, so that's 0x squared plus 3x minus 28. And then we'll go ahead and do that one just because it looks longer for the one that I do. So I'm going to put the 8 from over here, what I'm dividing by, in the box. And then I can use these coefficients, making sure I include that 0. So you always just want to check and see if there's any terms missing. I have my 4th degree, 3rd degree, my squared term, my quadratic term, my linear term, and my constant. Bring the 8 down and multiply. 8 times 8 is 64. When I add those, I get 0. 8 times 0 is 0. When I add those, I get 0. 8 times 0 is 0. When I add those, I get 3. 8 times 3 is 24. When I add those, I get -4. Reminder that that is your remainder. So I should have my constant, my linear term, my quadratic term, and this should be my cubic term, which if I look, 8x to the 4th divided by x, that should be giving me an x cubed for that term, an 8x cubed, but for that term. So if this is 8x cubed, 0x squared plus 0x plus 3, and then plus -4 over x minus 8. Now you do not need these zeros here. Like for my answer, I'm not going to write them kind of like for the original problem. They weren't written in it. It's not simplified. So I'm only going to have 8x cubed plus 3 plus -4 over x minus 8. I showed them here so that you could kind of see how all the zeros lined up for each different term.